Hello, good morning. This is Nas from NV Network Lessons. Hope everyone's doing okay and having a fantastic day. Today, date is December 27, 2024, and we are going to solve a problem which pertains to equilibrium. Okay, I discussed in my last lecture and I introduced you what an equilibrium is. I defined equilibrium in terms of physics and in terms of general knowledge. Okay, but today we're going to solve a problem which involves equilibrium. But before I dive into the problem, solving the problem, I would just like to go over Newton's second law of motion. Newton's second law of motion is the most Newton's law, which is used when you solve the equilibrium problems. So for all the high school students, college students, this is really essential that you pay attention. So Newton's second law of motion basically states that force is equal to mass into acceleration. All right, there's no question about it. And this is a vector form. So I'm going to put this arrow on top, and this right here is a summation of all the forces. Acceleration is also a vector. What is a vector? Vector is a component which has magnitude as well as direction. So acceleration is a vector. Force is a vector because it has a direction, okay, and has a magnitude. Acceleration similarly has a direction and a magnitude. So therefore, F is equal to ma. So I'm representing this in vector form. Now let me ask you this. Let's say you have a mass right here, okay? It's basically, let's say, a ball, right? So this ball has certain mass, and I'm applying force in this direction. I'm applying force in this direction. I'm applying force in this direction. I'm applying force in this direction, okay? Let me just fix this real quick, okay? So then my question to you is, if F1, F2, F3, F4, all of these forces which are applied on a ball are equal, okay, then the net force would be zero, okay? And also, point to note over here, if the ball is not moving, then there is no acceleration. Would you agree with that? If something is constant and it's not moving, it's an equilibrium state, but it has no acceleration. So then in this case, if acceleration is equal to zero, then the sum of all forces would be equal to mass multiplied by zero. Subsequently, all net forces would be equal to zero. There's no rocket science over here, right? Now, let's go ahead and dive in and look at the component form of summation of F forces in x direction and summation of forces in y direction. So let me write this down in component form. Okay, let's say you have y-axis, you have x-axis, right? X-axis, and you have y-axis. Okay, no rocket science over here. I've got a box right here. So if I'm applying force in the x direction like this, okay, and if I'm applying force in this direction, so let's call this f of x 1, let's call this f of x 2, right? Then if I want to write this in a component form, then I would say summation of f of x is equal to this f of x1 and f of x2 are equal and opposite forces. So the resultant force would be zero. Okay. So then I can write as f of x is equal to 0. Similarly, if you're looking at the vertical force downward and then this force going upwards, let's write this down. F of y is equal to 1, f of y 2. All right. And if these two forces, f of y1 and f of y2, are in opposite direction and equal, which will basically return a resultant force of 0. So then I can write summation of f of y is equal to 0. So how's that? All right. So let me just go ahead and erase this, and we're going to solve the problem now. Okay. So basically in this problem, what they're asking is that find the tension. Let's say this is a rope. Okay. This right here is a rope. Okay. This is a rope. And this is also a rope. Okay. And this ball right here, a metal ball, is in equilibrium. What they want us to do, they want us to find T1, tension in this rope, and T2. Okay, that's what we need to find. So how would we do that? How would we find that? Well, in the given is that there is a force which is also pulling the ball at a 30 degrees and it's 100 newtons. Okay, so how would you do that? What I do is that I draw a free body diagram. Let me show you what a free body diagram is. So in free body diagram, I draw something like this. I say this is T2, all right? And I say this right here is my ball, and this is T1. And this right here is the force T3, which is at 30 degrees. Okay. So then let's go ahead and see if we can find out component just in x direction. Okay. So then f of x is equal to 0. We know that because the ball is in equilibrium state. Okay. Now this tension T1 is pulling the ball up in its own direction. So it's pulling it in this direction. So then summation of f of x would be equal to minus T1. Okay. Because the ball is being pulled in this direction. That's why I have minus T1. Okay. Plus 100 times cosine of 30 degrees. Okay. If you look at this right here, basically, this is like a right angle triangle. Would you not read? Sine theta is perpendicular over hypotenuse. Cosine theta is base over hypotenuse. So in this case, what we are looking for is basically base right here. We're looking for base. So if I do base, then this will become h hypotenuse into cosine of theta. That's how I got this. So when you solve this, my friends, you will get basically minus T1 plus, when you solve this, you get T1 plus 100 times cosine theta, which is equal to 0. If you solve this, you get minus T1 is equal to minus 86.6 Newton, or T1 is going to be equal to 86.6 Newton. Okay. Now, what thing you have noticed is that even though we assumed in the beginning that yes, the direction is minus for the T1, okay, but once you solve the problem, it's basically telling you the magnitude. It's telling you that it's 86.6 Newton tension, okay, all right, even though we know that it's in this direction, okay. So even if you write the answer as T1 is equal to minus 86.6 Newton, in my opinion, that would be more accurate. However, in your books, they have T1 is equal to 86.6 Newton positive, which is kind of deceptive. However, this answer is also correct. And if you put a minus over here, that answer is also correct. Okay, because this tells you that it's in this direction, opposite direction. Now let's go ahead and look at the f of y, the y component. Okay, so when you do f of y, that is also equal to 0 because this ball is in equilibrium state. So then I can write this as T2, which is this right here. Okay, now this T2 is basically this tension right here is pulling the ball. So I'm going to put positive sign right here. And then this force right here, the y component, which is right here. Please pay attention. This component is the y minus 100 into sine theta is equal to 0. Okay. So when I solve this, T2 is equal to 50 Newton. Okay. So in this particular case, T2 tension is 50 Newton. This rope is basically pulling the ball up. This rope, the y component, is pulling the ball down. That's why I have this minus sign. All right, guys, thank you so much for watching. I really appreciate it. Stick with me if you want to learn more physics, math, calculus, probability and statistics, and so forth. Take care. Bye-bye.